Hello everyone. Today we're going to look at some tools for normal distributions that we can use on the calculator. And if you go into your distribution menu, that's in second and vars for distribution, then you're going to have two main tools that we're going to use. We're going to have normal CDF and we're going to have inverse norm. So I'm going to start with normal CDF so that you can see what that looks like. And normal CDF is going to be helpful if we have a z-score or some z-scores to build on, and we want to get to a proportion. And this is our structure that we're going to have. So if you've got a z-score, then you can get a probability out. The answer it's going to give you is going to be a probability. So lower than upper. So that means lower is what's my lowest point, what's my farthest left point I want it to be. Right now it's set at a really far to the left value. And then upper is what's the highest point that I want. So in this case for lower, I would want a really small value, right? If I wanted this area. My leftmost point is technically infinity, but we're going to go really, really far to the left. So -1 and then a bunch of zeros. All right. And then our upper, this would be our upper. Okay. Whatever z-score or value happens here would be our upper. So let's say it's at -1. So we're going to go up to -1. And then if you have a z-score, your mean is always 0, your standard deviation is 1. That's the point of a z-score. It makes it so that the mean is 0 and the standard deviation is 1. And so that would be your area to the left of -1. All right, and another way we can do that, another way we can use that is that if it were an upper tail, we would rotate around. So let's say here, now this would be my lower. Whatever value this is would be my lower. And then a really big number like 1 billion would be my upper. Because technically it would go up to positive infinity, but we're just going to put in a really big number. Another thing you can do with normal CDF is to just put in values for the mean and standard deviation and go straight from the values that you want it between to your answer. So let's say, I've got something that's supposed to last a year, and so the mean is, and I want the probability that it actually lasts more than like 367 days or more. So then my lower would be 367. And then my upper would be a really big number. And then I could have a mean of 365. And then a standard deviation of whatever the standard deviation is. 1.23, let's say. And then go straight from the values, instead of having to compute out the z-scores, to the answer. Now, you would need some more work shown on the paper. But that's another way you can use it. And if I want values in between, then that gives you what you would use for lower and upper, right? You would have maybe if you wanted between 363 and 367, you put 363 in as your lower, 367 in as your upper, and then your mean and standard deviation. But if you're going from z-scores, mean is 0, standard deviation is 1. So that's your normal CDF: lower, comma, upper, comma, mean, comma, standard deviation. Now, inverse norm asks a slightly different question, and hopefully you can tell what it is by the fact that it says area. Area means I have this area that I know the area, and I want to know what this value is. I want to find the value. So instead of giving me a probability as the answer, This time we start with the probability and are trying to get to the value or the z-score. So it works the other way. This is useful for answering questions like, what's the 20th percentile of the distribution? So let's say we know that this area is 0.2. It's always area to the left, so it's in terms of percentiles. 0.2, and then mean of 0, standard deviation of 1. This will spit out a z-score. So this will tell me what the z-score of the 20th percentile is. Negative 0.841. And then same thing as before. I could put in, if I wanted to, what was the 20th percentile? I could put in the mean and standard deviation. Again, you would need to show work on the paper being clear that that's the mean and standard deviation. But you could have your mean of 1 year, 365, and then 1.23 is your standard deviation. And then it would tell you what the 20th percentile was. Boom. 363.9648. That would be where the 20th percentile is with that mean and standard deviation. So just to recap, normal CDF is if we know a value or a z-score, and we want a proportion or percentage. And then inverse norm is if we know a proportion or maybe a percentile, and then we want the value or z-score. Okay, that's what each of these are for. They're kind of the opposite of each other. Depends on which thing you're given. If you're given the area or the proportion or the percentile, then you're going to use inverse norm to go backwards to the z-score and the value. If you already know the value or the z-score, and you want to know what's the probability that it's between these values, or that it's greater than 20, or what proportion of values are between these two, then that would be your normal CDF. Lower, upper, mean, standard deviation. Inverse norm, you put in your percentile, and then mean and standard deviation. And for z-score, mean is always 0, standard deviation is 1. And that's about it for the basic rundown of normal distributions. I'll talk to you next time.